Hello, everyone. Welcome to this year's the 2023 Brown Bagger Luncheon from the NBCEC, National Beef Cattle Evaluation Consortium, which, as many of you know, was something that was started years ago with some federal funding. And this is pretty much the last activity other than our website that we still have going on with it. But this has been, I got to check in my records. This is, I think, our 19th year. Next year, we'll have our 20th anniversary of hosting the Brown Baggers. So we appreciate you guys sticking with us. We have good attendance every year, and as long as we keep having good attendance, we'll continue to try and put these programs on. So just to remind you, the overall theme for this for the brown bagger this year is current and future tools to improve genetic selection decisions. I'm your host today. My name's Darrh Bullock, along with Bob Weber and Matt Spangler. We're kind of the education committee for this that puts this program together every year, and I appreciate my colleagues' help on this. And I'm at the University of Kentucky. As I said, we still do have the website, and that's where you can go find the archived information from these. We have most of it archived going back. It's also, if I'm not mistaken, we have a good bit of it archived also in the eBEEF.org, and so that's an option as well. We still, the other activity that we have is the sire selection manual. We have our third edition. If any of you are interested, we have that online as well. If you need hard copies, get a hold of me and I can probably help you out with some in that regard as well. First up today is no stranger to this crowd. It's a good friend of mine and colleague, Dr. Matt Spangler from the University of Nebraska. I pretty much know his little bio by heart, but I'm not going to go through it because, as I said, I think he's very familiar with you guys. Matt got his, is a Kansas native anyway, Kansas State, and then got his PhD at the University of Georgia. Been at Nebraska now for a number of years, where he's a full professor. And as a lot of you guys know, Matt's done a lot of work in the selection index area, and that's what we wanted Matt to kind of focus on today. The title of Matt's talk is going to be Profit Focused. Make sure your selection decisions are too. In other words, we want you thinking about profit there as well. And so if I can figure this thing out, Matt, I'm going to turn control over to you. And appreciate you being with us. I think you can take it.
Sounds good, Darrh. Thank you for that introduction. Appreciate the opportunity to visit with the group today. So we'll get right into it here. Assuming I can. There we go. So the part of the thesis, I guess, of this is that a sire selection decision or a genetic selection decision more generally is a capital investment in genetics. And beef cattle producers are faced with the problem of obtaining the best bulls conditional on their unique setting. And best becomes a relative concept because what's best for me may not be best for my neighbor because our situations differ. And the reality is that a less desirable bull could become the preferred choice if his sale price discount is large enough. In other words, we need to think about return on investment of the genetic selection decision that we make. One way to help quantify the value in terms of net profit potential between two bulls, of course, is an economic selection index. And this theory has been around in animals since the 1940s. You can go back to the 1920s in agronomy settings. And the beef industry, I think pretty much all major U.S. beef breeds have at least one index, and those have been around in general since the early 2000s. In principle, they're tools to select for improved commercial level net profit. And that's a really important thing to understand. These are tools to enable change in commercial level profitability. And they're based on breeding objectives, of course, economic parameters, so the costing of feed, the value of weight sold, the relationships among traits, and then also something that I'll focus on more today is the population, or if we think about a producer's unique situation, the herd mean. So what is the average weight, an example, which I'll show can have a large impact. At the same time, though, I think those of us, particularly in extension, have heard for years almost a demand for some kind of decision support to help accommodate those unique situations that beef cattle producers find their enterprises in. And this notion of decision support isn't new either. And I'd encourage people to go see a really nice paper from Scott Newman and others in 2000, which details a bit of a historical view on decision support and successes and failures. There are some that I'd highlight that have been been available at some point in the U.S. The Colorado Beef Production Model, DESI from the U.S. Meat Animal Research Center, and then more contemporary but a bit dated still are efforts between Colorado State University and the Red Angus Association. And there's been failures. The reasons for lack of success are complex, but basically you can boil them down to some of these systems required very complex input. They attempted to be too comprehensive, and as a consequence were too clunky for some users. And I think a big part is the long-term sustainability of the application was a large challenge. In other words, the funding of the effort, the maintainability of the software were problematic. So with that in mind, a group of colleagues from the U.S. Meat Animal Research Center, Kansas State, Bob Weber, and then Theta Solutions, namely Bruce Golden at the time, and I got together to try to resurrect this notion of decision support with user-specific economic selection indexes in mind. And so we developed what we call iGenDec, which is now available through the Beef Improvement Federation. The software that underpins this web-based application was written in the Go programming language. May not mean a lot to a lot of you, but the point is it can run from a web interface, which I'll talk about, or from command line. The run times are really fast, so generally less than a couple of minutes, but does increase as we increase the length of the planning horizon, which I'll discuss in more detail. And it has a few primary parameter files that include breed effects and the genetic and residual variances and covariances, and different economic index files that include user input values for sale prices and costings. But the point is that we've tried to take what could be to some complicated linear algebra. We've done that behind the scenes, coupled with stochastic simulation, to allow the user then to focus on what they know about, which is the unique situations of their specific herd. How we parameterize this was largely based on literature or values from the U.S. Meat Animal Research Center. And at a high level, the user defines parameters about their herd, and the system simulates a very large beef cattle population. And what it does is it perturbs the genetic values of sires, one trait at a time, resulting in one unit change in offspring phenotype. And we take into account this notion of discounted gene flow, which means that, yeah, a sire impacts the genetic value of his calves, but also his grand calves as well if replacement females are retained. After a burn-in period, it's run for a specified length of the planning horizon. So this reproducing simulated cow herd will continue for a number of years defined by the user. Then there's simple accounting based on the simulated phenotypes, and that enables the calculation of the marginal economic values that are used as the index weights that can then be applied to a group of selection candidates or the bulls that somebody's wishing to rank. So I'm going to take you through relatively quickly some screenshots that a user would see And this is how they would begin, by choosing a sale endpoint of their calves and an index type, which is basically, do they retain replacement females, yes or no. Once somebody actually runs a job, that job can be saved with any comments from the user, so they can go back and look at results at some point in the future, or perturb an existing job. After the user completes that page, the system check marks a group of traits that it recommends be in the user's index. That can be changed by the user if they so choose. And the user can also specify the length of the planning horizon. That's really the length of time in years that you wish to contemplate the costs and returns from a genetic selection decision. And we'll talk about the impact of that, but I think it's a really nice way to think about, again, a genetic selection decision as a capital investment. The user can define a length of breeding season, the conception rate within that length of breeding season, and the calving loss due to dystocia. This is where the user begins to tell the system about their current herd, which helps determine what the marginal economic values of perturbing certain traits might be, given their unique situation. I've skipped over the cow age distribution just as a function of time, but the user can tell the system what's their maximum cow age, how is the distribution of cows across cow age classes, which begins to impact traits like stayability. Of course, you can define what breed or breeds your herd is comprised of. Here I have a listing of breeds. We also have Wagyu. It's largely breeds that have a genetic evaluation. And the user can form their own composites as well, by determining different fractions of the breeds available. Here we get to annual cow cost, annual variable cow cost, which can be on a per year basis, or it can be broken down by month. And then here, this is for fed cattle, a pricing schedule on a hot carcass weight basis, as well as premiums and discounts based on quality and yield. Can also take into account different programs, taking an example, certified Angus beef. And then lastly, here a page that might include how calves currently perform, so averages for different carcass and growth traits, as well as feed intake, and then some parameters around feed costing and number of days in particular segments of the industry. So a good question is, well, how might somebody choose parameters in terms of economic costs and returns? Well, that'd be tempting to forecast into the future, because that's when the calves would actually be sold. But if you're that good to know what the future costs and returns would be, you probably just need to sell your cows in day trade. If you use current values, it's already outdated when the calves are actually marketed. So the best thing to do is use historic values over a longer time horizon, like 5 to 10-year averages, because really what you want to do is capture the relationship between costs and returns, and over a cattle cycle does that very well. In terms of what phenotypic averages to use, you want to use current values, because that's where you're starting from. Of course, the output then is these marginal economic values. These are in dollars per unit of the trait, and these become the index weights then that can be applied to the corresponding EPDs for these traits. So let's get into some situational examples and how these things might actually impact selection decisions. I've got two I want to highlight. If we change hot carcass weight from 850 all the way up to 950 pounds, assuming there's a discount threshold at 1050, what does that do to our indexes? Or what if we lose 0% of calves due to dystocia now, and that increases to a 2% death loss? What does that do to the impact of a trait like calving ease direct? Here I have pie charts. And these represent the relative emphasis of traits in our breeding objective. The one on the upper left, a really small blue sliver, is the impact of calving ease direct. And so if we're losing 0% of calves due to dystocia, the system would say you don't have a problem. In terms of your breeding objective, this trait isn't important. But if we start losing 2% of our calves due to dystocia, the bottom right, Now the relative emphasis of calving ease direct is upwards of 10%. What this says is, if I don't have a problem with dystocia right now, but I still place selection pressure on calving ease direct, I am making a decision that is not economically optimized. Perhaps I'm risk adverse, and that's why I do it, but I'm potentially leaving profit on the table by doing that. Interesting story here with calving ease. If I go on the top left, or pardon me, with hot carcass weight on the top left, there's 41% of the emphasis on hot carcass weight, but that goes down to 39% and all the way to 32% as the hot carcass weight average increases, because the mean is getting closer to where calves would incur a discount. And if the mean's getting closer, that means there's a larger proportion of calves that are actually crossing that discount threshold. So where you start from, particularly if there is pricing thresholds, can impact how important a trait is for your particular breeding objective. I'm going to quickly switch gears here and talk about where, in my mind, economic selection and environmental footprint merge. And the reason I want to emphasize this is because we hear a lot about selection on traits that may reduce the environmental impact of beef cattle enterprises. And I believe that genetic selection is well suited to reduce environmental footprint given its cumulative and permanent nature. But to do so, selection decisions need to contemplate long-term profitability, because if they do, implicitly they consider environmental stewardship. But that path towards long-term sustainability is different for each enterprise, because where they begin on that path varies. So if you want to select for reduced environmental impact, you have two choices: develop genetic predictions for direct measures of it, enteric methane, water consumption, etc. Or, I would argue, reframe existing selection tools to emphasize traits that increase in value over longer time horizons. And I'd note that these two options aren't mutually exclusive, but number one is arguably going to take a while to materialize, and I'm impatient, so I'd rather focus on number two for right now. And we do have some tools at hand. There's good previous work from Peter Amer in the late 90s and a current student of mine more recently that's shown the impact of planting horizon on the number of discounted expressions for various traits. The way to think about discounted expressions is, if I take a decision on a sire today, there are some traits which aren't going to be expressed until much later. So stayability isn't expressed as early as weaning weight changes are. And so if I have a longer term view on profitability, I might emphasize things that are expressed later in life more than if I have a shorter term view on profitability. And there's a lot of reasons why this might matter: overall efficiency of resource use. We could argue changes in mature cow weight impact enteric methane production, maybe more methane intensity than raw production. And certainly there's evidence from the dairy industry that improvement in reproductive longevity has a beneficial impact on enteric methane intensity. So I'm going to show you just three case studies here. One where I changed planting horizon, that's pH, from 2 to 10 to 20. And I built a comprehensive index that assumed we retain replacement females and all else are sold on a value-based grid. And I just wanted to isolate in on the relative emphasis of hot carcass weight, which is HCW, stayability, and mature cow weight, which is MWT. And as planting horizon length increases, I think it's intuitive that the relative emphasis on traits like stayability and mature cow weight, which are expressed later in life, also increase. So if I have a short-term view on profit, I'm going to select heavily on the weight traits only. But if I have a longer-term view on profit, then traits like stayability or mature cow weight will increase relatively. Now, what if I increase the annual cow variable cost from $250 to $500 to $750? Again, I isolate on these three traits, And what happens is annual cow cost goes up, but value of calves sold stays the same. The emphasis I put on mature cow weight dramatically increases. Of course, the marginal economic value here is negative, meaning I want to push mature cow weight down. Interestingly, stayability, the relative emphasis tends to go down as well. It's still important, but if cows are getting bigger and the value of calves isn't changing, then the system would see more value in younger females, which tend to be lighter weight. Lastly, I want to look at changes in hot carcass weight. This is actually in pounds, going from 700 to 800 to 900 pounds. Discount threshold at 1050. What you see is the relative emphasis in hot carcass weight going down, but the relative emphasis in stayability actually going up. And that's because there would be value in actually sending more heifers to slaughter because they tend to have lighter weights. At the same time, there'd be value in just older, more mature females because still sending more weight through the system would be economically rational. Two take-home messages, honestly, from these past 3 slides is that where we are as an industry or where you are as a producer in terms of your current herd performance should impact the relative emphasis on traits and breeding objectives. Secondarily, the trade-off among traits can be complex, particularly these last 2 slides that I showed you. And I think really looking at systems modeling using stochastic simulation helps us elucidate what those trade-offs actually are. So this software, I mentioned it can be accessed through the Beef Improvement Federation. We're currently working on a beef on dairy implementation of this as well. For those that actually want to look at the source code, it was checked in the original grant version to GitHub by Bruce Golden. And I'd just like to round out by saying that new tools such as the decision support application I showed you alone do not enable selection for sustainability. To quote Slowhand, it's in the way that you use it. So with that, Darrh, I'd be happy to turn it over to you. Oh, and quickly thank everyone that was involved in the creation of iGenDeck.
I'm really pleased to be able to go ahead and present today and contribute. I've been a student of the Brown Bagger series for many, many years and am excited to contribute on behalf of Neogen today. So my name is Kari White, and I've been working with Neogen for about 6 years, I think now. And I'm a genetic evaluation scientist. I run the evaluations for our breed association customers and several large commercial systems. And almost all of them have some form of Indicus influenced in them. And I know that in the past, those breeds have kind of had a reputation for being low fertility or difficult to get pregnant as heifers. But our partners have really worked hard over the last many years to select against that and have females that are fertile. And so that's what I'd like to talk about today. See if I can get the slides to advance. There we go. Okay. So traditionally, reproductive traits are hard to select for, really hard to have in a national cattle evaluation because they're lowly heritable and they're generally threshold models. And there's lots of challenges in that. You lose some of the variance in threshold models. They also take longer to converge. And it can be difficult to use those as a producer because you have to think about what units they're in. Heifer pregnancy or breed back pregnancy being a probability that can be not as intuitive if you're trying to implement it in a production system. And so what we've tried to do at Neogen with our genetic evaluation partners is say, how can we create traits using data that producers already submit to us, like calving data, that are more intuitive for breeders to use, but then also, computationally easier and more efficient. And so that's how we came up with number of calves and age at first calf, both reproductive measures using calving data that's already submitted to associations and with our commercial partners. So number of calves is the number of calves an animal has to 7.5 years of age. And age at first calf is the difference in the day that a cow calves versus its contemporaries. So as I said before, number of calves, that's where we'll start, is the number of calves an animal has at 7.5 years of age, given she was selected as a heifer. So the data here can be different depending on what data you have. Our association customers usually say that any female that has yearling information is put in as a replacement heifer. Our commercial customers usually actually have that data saying we kept these females as replacements, and that's what we use. It's not consecutive. I know a lot of evaluations use stayability, and those can often be how many consecutive calves did a female have. This is not the same as that. Twins also count as one record or one calving. And so the way this looks, very practically is a female calves as a heifer or not. She can also receive a 0 for that year. And then you'll just have several years of data with a success or a failure, essentially, and then you count those, and that's the number of calves that she has. The drawback of this trait, like so many of our other traits collected later in life, is that younger animals don't have a record until they reach that 7.5 years of age. And the thing I like about this trait is that it can be flexible in terms of contemporary grouping, which is almost always the crux of the issue in genetic evaluation. You can use the contemporary group, like I said, or you can use a birth year if you don't have yearling contemporary group information, which some of our commercial partners do not. So number of calves is run as a continuous trait, and what I really like about that is that convergence is quick, and the heritabilities are notably higher than some of our other fertility traits. In the 3 data sets we've looked at this in, it's often twice as much as sort of a traditional stayability. And it's also highly correlated to other traits that are measured earlier in life. So heifer pregnancy breed back, which is kind of that probability of a second calving, age at first calf. And it's a pretty notable correlation, roughly the same as the correlation we see between the scan and carcass traits. So the first breed we looked at this in was actually Brangus. The International Brangus Breeders Association is where we first started this work. And you can see they actually have quite the suite of reproductive EPDs. Not all of these are published by themselves individually. They also have a fertility index, and a lot of these are cooked directly into the index so that their breeders don't have so many EPDs to look at in a sale catalog. And so just looking at this, kind of the take home is females that have an age at first calf that's younger tend to have higher number of calves. And it's also very likely that if you're selecting for stayability, rank-wise, you're going to pick the same animals as if you're selecting for number of calves. And so I think you could ask the question, well, then why would we change to using number of calves and not stayability? And I think it's because, 1, computationally, it's easier. 2, the heritability is higher. And 3, I think it might be more intuitive for a producer to look at a number that's continuous. As in, this is how many more calves this female would have compared to her contemporaries. And so that's why I think it's very usable. The other trait we've been looking at is age at first calf. That's the difference in the day a cow calves first versus its contemporaries. And so a lower number means a female can calve earlier in the season. And the data for this is actually just the number of days between a cow's birth date and her first calf's birth date. So again, this is data that's already in the system being produced. You're not asking for any more data from your breeders. I worked at a breed association. I know that's difficult. And the caveat here is that we set a threshold that the calf is born in the first 1,050 days of a female's life. And the reason we chose that number, which seems arbitrary, it's less than 35 months of age. And so we're saying, are you actually trying to calve her as a heifer, essentially? So again, here, the contemporary grouping is flexible. You can use the yearling contemporary group info with or without a weight, really. You can group her as a yearling without a yearling weight, or the yearborn of the female as the contemporary group. The other thing here you can do is to use the birth contemporary group slice of the calf that she has. So we have 90-day birth windows in lots of our evaluations for calf contemporary grouping. And those can be very useful because in Beefmaster, for example, there is some concern that lots of the females are bred to calve at 25 months, but lots of them are also bred to calve at 30 months. And so the question was, do those animals get unfairly weighted for this EPD when they're actually older? You know, is the contemporary grouping taking care of that? And I think it does if you use the slice on the calf's birth date. We took a look at both, running those as separate traits and then running them together. And the fact is that they rank the same. Animals that are going to get pregnant younger will rank as getting pregnant younger in both of those EPDs. And so this is highly correlated to other longevity traits measured later in life, which is why it's effective. So this is the age at first calf phenotypes in Beefmaster. I think the concern sometimes with fertility traits, maybe specifically in Indicus cattle, is there enough variation to select on? And I definitely think there is. So this is in the Beefmaster breed. And then these are the EPDs of age at first calf in Beefmaster. So still a really good distribution here of animals with lots of room for selection improvement. We've also seen some breed interactions with fertility traits. We've implemented these in these EPDs in King Ranch. And if you don't know where that ranch is, it's very south of San Antonio. It's hot, it's dry, some part of the year, and then it can be really, really humid as well. And so it's a tough environment, and they've got to have a certain amount of Indicus in their animals for them to survive the summer, and certainly to breed, for bulls to breed and to get pregnant. And so one of the first questions that we were asked by Darrh, who's the cattle boss at King Ranch, is, so how do I select for bulls with these traits? And so we actually looked at how they correlate to scrotal circumference in bulls. And we saw a really interesting interaction here, pretty unexpected, which is that bulls with a higher average scrotal circumference had females with a lower number of calves and an older age at first calf, which is opposite of what I expected. And so we looked into this a little bit and, kind of took into account where that ranch is. And we think what's going on here is an obvious environmental interaction. So King Ranch has lots of Santa Gertrudis in their herd. And those bulls don't have a pendulous round sort of scrotal circumference. It's more oblong. And I think it's a heat tolerance sort of thing, trying to get the scrotum away from the body so that they can continue to produce semen. And so those bulls are the ones that survive to reproduce and produce females that are more heat tolerant in the environment. And the ones that are a little bit more British type will have those round scrotal circumferences, and they just don't do as well in this particular environment. And so this kind of illustrates what I'm talking about here. We see this in the females. This is the percent Santa Gertrudis of females at King Ranch versus the average number of calves and average daughter age at first calf. So here at King Ranch, if you have a greater percent Santa Gertrudis, those females will have a greater average number of calves versus if they have a greater percent Santa Gertrudis, they will get pregnant earlier as heifers. So they'll have a lower age at first calf, which is what we want to see. The other thing, and this kind of just illustrates what I was just talking about, is that it can be moderately correlated with scrotal circumference. These age at first calf and number of calves EPDs can be moderately correlated with scrotal circumference. They were in Bringus, but very unfavorably correlated at King Ranch, I think, where we really see a true environmental interaction. And the other thing to note here is that the heritability of these traits is much higher in sort of these closed commercial systems than it is in sort of a national cattle evaluation like the Bringus Association. And I think that that's because we're really working on sort of reducing environmental variance in those closed commercial systems, even to the point where it's just one person that loads the data into the system. That's very different than a national cattle evaluation. And so I think it does reduce error. So I just want to thank everyone for your time today, and also thank you to our genetic evaluation partners at Neogen that have been working so hard on these traits and also being willing to let us show the data that they've collected over time. So that's King Ranch, the Beefmaster Association, and the International Bringus Breeders Association. Thank you for your time. I'm happy to answer any questions.
Thank you, Kari. And Darrh apologizes for the technical difficulties. For the attendees, if you have questions, please put them in the Q&A. I'll start out with a question for you, Kari. You talked about the really count of calves trait. A lot of other breeds are using random regression for stayability, so dramatically different than the way it used to be. So there are predictions on younger animals. Missing observations are simply missing, so it doesn't have to be consecutive. So I'm curious about the choice of doing what you do versus, a random regression implementation.
Sure, that's a great question, Matt. We actually looked at some random regression, and what it came down to for us was sort of one, computing power and how quickly we can implement those kind of things with the same systems that we already have. And so these run very quickly. They were easy to implement in our existing evaluations. We do single-step GBLEP. And the other thing I think is our feedback from our customers has been that they like being able to plainly explain these to their breeders, especially number of calves. That's just so straightforward. It's a female has more calves at a certain age than her contemporaries. And so I think that that's the crux of the issue. They've got to be really intuitive to implement.
Thank you. And maybe one more quick question. You said you used a yearling group in some cases for the contemporary group definition. How do you account for the fact that some animals in the yearling group may never be exposed?
Yeah, that's definitely a source of error, and not one that we can account for right now in sort of the national cattle evaluations like Bringus or Beefmaster. I think the ideal data set would be that you would have exposure data, some way to say these animals were definitely exposed as heifers, because then that heifer could get either a 1 or a 0, as a success, as in she didn't get pregnant as a heifer. We do have that at King Ranch. They're able to tell us which heifers were used to breed. So.
Good. I see a question here from Darrh about indexes related to what traits may be missing in a lot of genetic evaluations to enable more comprehensive indexes. One of those would be mature cow weight. Obviously, not every breed has a mature cow weight EPD, and that's really a primary driver or best estimate at cost for cow-calf enterprises. Dry matter intake might be another one. So those two, I think, would be fairly substantial. Other questions? Bob, I'm having a hard time seeing the Q&A box.
I can see one, Matt.
Okay.
Someone asked what the estimated heritability is for the number of calves and how many records were available. So that varies. Usually we start looking at traits when there are above 2,000 records. So that was definitely the case at Brangus, Beefmaster, and King Ranch. We all looked at these traits when there were above 2,000 records. And the heritability range from, I think 0.05 was the absolute lowest, but the highest was about 0.12.
Other questions for either Kari or myself? I'll ask maybe one more, Kari. So, of course, it wasn't your task today to talk about how these things fit into indexes, but are these included in those respective organizations' economic indexes?
They are. And in fact, I think it is Brangus. I'm not sure if they actually publish these traits individually. I think they roll directly into their fertility index. All the breeds that we work with have been sensitive about not overpowering producers with a bunch of EPDs and really encouraging them to look at their index numbers. And King Ranch, in fact, really selects heavily on their index numbers, almost mainly, and just uses the other traits as a guardrail. So.
Well, I'd like to remind the group of what will be the second session coming up a week from today on October 11th. The theme of that is going from an abnormal calf to a genomic test. And your host again that week will be Dr. Darrh Bullock from the University of Kentucky. We'll have two speakers, both from the University of Nebraska here in Lincoln, Dr. David Steffen, who will talk about investigating novel phenotypes and what are the resources, the epidemiologic and sampling considerations. So really the whole notion of you have a calf that appears to be abnormal. What do you do then? And then a colleague right next door to me, Dr. Jessica Peterson, will talk about using genomics to connect novel defects to their origins. So really, once we're able to confirm something that is indeed a genetic abnormality or a defect, as we may say, how do you then begin to sleuth out, one, is it under genetic control, and then who was the progenitor of that defect, hoping to go all the way to a diagnostic test.
So Matt, I think I got one more, I have one more question from Darrh.
Okay.
He said, can you discuss your breed back EPD that we're working on? And actually, Neogen provides the breed back EPD for several of our breed association customers and most of our commercial customers already. And that's just the incidence that a female would breed back after her initial calving. So she's a heifer. What are the chances she's going to breed back again? Since that actually does seem to be, and I think, Matt, right, for all of the different breeds, that's maybe the worst pregnancy, the one that they will soonest drop out in, maybe even above heifer pregnancy. And so that's an EPD that most of our associations publish.
Yeah, you're right. That certainly is the challenging time. I think, and obviously outside the scope of today, but a question is, what do you capture with those other traits that would not be captured in a, kind of a stability type evaluation? But no doubt that second time is the hard time. That's where you see fallout. Well, if there are no remaining questions, after the plug for next week's, just remind you that at some point after all of these sessions are completed, the recordings of these will be up on the NBCEC website, as well as Darrh mentioned before, on eBEEF.org. So if you miss one of this year's sessions, or you simply want to go back and review it, those recordings will be made available to you. So with that, sincerely appreciate what was a very large attendance today, and look forward to seeing everyone back here next week.